I was up in the attic today and I grabbed this one, and this is an old C64. I don't remember how I get hold of this, but probably I bought it cheap many years ago because this was stored almost on the inner part of my attic. And as you can see, this box is not in great condition. You are able to make out some serial number stuff here, but nothing much. I don't think everything is in here. I don't think there is a power supply. Maybe that's what's gone out of the side of this packaging sometime. But here you can see there is a rather yellow looking bread bin and an RF cable. And this is a made in England unit. And I will check the serial number against what was in this box. 505, yeah, 607505. So this box is at least original to this unit. And I have not tried this, but I suppose it works. I'm in a kind of a jam with these C64s. I love to repair them, but mine seems to work most of the time. And we just connect this up and see what we find. I will adjust the camera angle a bit, like so. And we can try it out before we start it. You can take a look at the case. As I said, this is a made in England unit, and that means that it has the box, no writing on the side, and the rather flimsy covers. You can see here these thin lines here in the back. This is the very thin plastic brackets that hold this back, so if anyone has ever opened this, probably the plastic brackets would be broken. And I'm just going to take the lid of this. And it looks to have the original screws. And this is something I've seen on the made in England cases before. If I just take out these screws, you will see here. This is the most shiny screws you ever see. Normally these screws are rather grey on the C64s, but on a lot of the English cases these are totally blank and shiny. Put these aside. Let me try to ease this up. And yeah, it looks rather intact, so I don't think, oh yeah, this is broken. And we didn't break them off. No, so someone has actually been inside here before. And if we just try to see if everything is installed and in this, yes, it seems maybe there has been some work done on this, maybe not. It's a lot of socketed chips. That doesn't mean anything. It can mean that the board has gone some extra rounds on the Commodore factory. I just plug in my modified power supply, and I also need video signal, like so. And we just turn this on. Yeah, and just my bad luck. We have a totally fine working Commodore 64 with a rather nice picture. It does have a bit of redshift, but that's not unusual. We will take this apart. Since this is a UK made machine, it's assembled late in 1984 or early in 1985, I think. I will just disconnect the keyboard and this, and might put this one on top so I can see. Yeah, like so. And we will take a closer look. Yeah, I will try to zoom in a bit on this board. Yeah, like so. And we will see what we have here. And as I said, it looks like someone has been inside and done some work before, because there is a lot of socketed ICs. And that's not very unusual, but it's quite unusual that there is sockets to this extent. And actually it does not seem like there is much repair work done on this. It's 250407 board with the revision C. I know we repaired the revision B here earlier. I can't remember if I worked on another revision C in my Resurrection series. But what we can do is take out this motherboard and take a peek inside to see if there are some more signs of rework on this machine. And these are also shiny screws, shiny. And I know someone like Adrian Black, he complains a lot about the RF shields, and my C64 that I had originally had no RF shield at all. And I do remember my parents getting mad because this made a lot of interference on our TV set. But I made a custom RF shield out of thin metal sheets and put both on the bottom and the top of the case, and I actually managed to make it a lot better. But the RF shields on the C64, at least on the European TV signals, made a lot of noise. And my first C64 was the original C64 board that was the same as the silver label boards. Yeah, I will just put this away while we take a peek. And as I've said before, this board with the tinned traces is actually my favorites because these are very solid and it's difficult to break. If we zoom in here and see a bit on the soldering that's done, as you can see, all this soldering is very nice and shiny. And where there is some extra solder is here on these pads here. But the TV modulator was mounted after this was soldered by a solder bat back in the factory. So that is not unusual, neither on the pins to the cartridge port for the shield. So I do think that this is original, never worked on before. And that means that all the sockets that's here are factory. And that leaves us with another mystery that I've saw just when I tried to, because here you can see a Commodore at its best. Here is the 8 RAM chips on this machine, and these Oki chips here, this one has a production date, I'm not sure how to read this, but these 3 chips are totally the same. This is a neck chip, and these 2 here are also neck chips, but they're both a different type designation and a different speed labeling. They're actually D4164Cs both, but this is a -12 120 nanosecond, and this is -3, and I can only suppose that this means 300, and that's not within spec for a C64. And you have this other neck chip here. These 2 are quite similar, and here you have 1 Micron chip and you have 1 Texas Instrument chip. So actually on this board you have 1, 2, 3, 4, 5 kinds of RAM in an original out-of-the-door factory-made C64, and that's quite extraordinary, I think. And you can see here the 4066, they've actually been socketed, and these 2 have been socketed. And there are 2 reasons why boards left the factory in Commodore's world with sockets, and that was if the board actually didn't pass the first test, then they were taken back and reworked. But most of the rework you are able to see afterwards. So the other reason that they made this was they was missing some of the chips, and they didn't put them in until afterwards, and instead of that they made sockets, and the ships was put in by the assembly line. And not every one of these ships of course have manufacture dates on them, but the 6510 is labeled 84, 14 week, and the 6526 is 0884. And this is a very early revision 6581 with no revision number, also made in 1984. And you have a PLA ship here that is also made in week 1284. And you have some date markings here. This Motorola ship 78 LS08 is 8405. Yeah, this is actually 82, 81, 8401. 8402, 04, 84, 83, 52, late 83 on this next ship. I'm not sure, 4287. It might be just a counter number. And this one that was socketed does not have a readable date, neither do these ones. And you can see that this machine has hardly been used. This cassette port here only have very clean contacts, but you can see that there is no scratches. And there is no scratches at all on the user port. And everything looks bright and shiny. So except that the case has gotten yellow over time, this does not look to have been used anything at all. Yeah, it's a very early revision. It's a P3 6569 from week 38 in 83, and very crusty this thermal paste, and everything else looks to be quite okay. I do think I am the first one to actually open this ever after it left the factory. I will fix the thermal paste on this. And it also uses the old school socket for this. This socket was actually a bit loose in the plastic, but not in the soldering. Might have got a dent when it was stored. So this C64 was a kind of a surprise. It actually works perfectly. Lot of sockets and still no rework done on it. So I will try to give this a test harness test to see if it actually works. If it works, that's fine. If it leaves us some errors, then we do have something to work on. And that would be nice for a change. I do see that this capacitor here looks a bit brown-ish around the tint here, but I do think that is soot from the original solder that went on here. It does not appear to have been leaking at all. I never actually encountered a C64 with a bad capacitor. They have all worked. And that's a statement that's coming back to bite me later in this video. There is a first time for everything. But not everything is lost. We do still have a chance to find a fault on this C64. So let's connect the test harness and give it a try. The sound output on this was very weak, so I do have to make some secondary measurements or test my setup here, because I almost could not hear it. So I run the test for a second time after checking my connections. Yeah, I speed this up a bit until I come to the sound test. Yeah, the SID and the sounds from this machine is really, really weak. I almost could not hear a thing, and I couldn't hear some of the sustain and voice and filters. So I don't know if this is good or not. So I have to test with another SID device in this computer to see if it's okay, and I might also have to check my test setup to see if something happened since last time I used it. So the next step is to try another sound chip. Yeah, and I try to pry this out really carefully. You know, the sound chips in these devices is really rare, and this one that is really old and it might be working as it should still. So I think it's best to keep it safe and handle those carefully. And I will replace it with something that is even rarer. This is a ARM SID. That's an original replacement for the SID chip. And again, we speed up the boring parts and jump to the sound test. Yeah, that sounded a bit different, but not by much, and it still was very low. But I did think I could hear some of the voice channels, so maybe it was a bit better, or maybe at least different. To make sure that we are not on a wild goose chase, I will test with another C64 with the same test setup to see that we are able to get the sound straight, and this time I do an open air recording with loudspeakers and the mic. So that means that there actually is a fault on my old bread bin motherboard, and that is that the audio is weak to the output, and I of course have to look into that. That is a fault I can't remember to ever have encountered before. So that will be a follow-up to this. I will have to look into the sound output and how it goes until it reaches the audio video output plug where we have connected our both loudspeaker and amplifier and also the recording device. Yes, and what possibly can go wrong with the sound on a C64? And we saw that we changed the sound chip. We did change that to an original SID. That's the ARM SID we tried, and the sound was just as weak as it was when I tested with the original SID chip that was in the board. And what can possibly go wrong? That is a good question, and this is the audio out of the SID chip, and it enters to a resistor network here that drives a base on an NPN transistor. And you see that this transistor here is tied up to 12 volts, and there is no resistor here. And the output is actually driven over this resistor that is coupled to the emitter of the transistor. And this kind of emitter coupling amplifier circuit is meant to not amplify the voltage or the amplitude of the signal, but it's meant to strengthen the power output, and that means that you can draw a much higher current from here than you actually deliver out from this chip. And this could be maybe 10 times something. It probably is, because this is a 1K and a 10K resistor. So this will actually be outputting the same that is in here, but with a 0.7 something lower voltage here and a much higher current output, or be able to drive a much higher current output. And you can see this is also coupled by a capacitor here and direct to the audio out. And this capacitor means that there is no DC voltage delivered to pin 3 on the audio out, only AC voltage. And you can also see that this is directly coupled to the audio input of the RF modulator. So that means we have the following sources for faults. We can have a short in this resistor here, not very likely. We can have a break. This is a ferrite bead actually. This is just a wire with a ferrite bead around it, and it's meant to suppress noise. So this is just a wire through here, and you have a 10K resistor. This 10K resistor can of course be broken. It probably is not. 10K resistor with this kind of power draw is almost impossible to burn. It is not enough voltage or power available to burn a resistor like this. And you have a 1000 picofarad or 1 nanofarad capacitor that goes to ground. And of course, if this capacitor is shorted, you will have the signal go straight to ground to this 10K resistor, and that will short the signal over the base here, so you will get no or a very weak signal over the base here. That's not very likely that these resistors or this capacitor is shorted like this. It can of course be, but it's not very likely. So we do have some other sources of fault. It can be the 12 volt here that is missing. This base emitter here will still be able to drive this transistor, because this acts as a normal diode this way when there is no collector voltage. So this diode here will leave us with a 0.7 lower voltage here, but no current amplification, and that of course means that if we drive this output, it will get a very low signal. So the most likely component to fail in this scenario, if you do have the 12 volt here, this transistor here is probably gone, or that there is something inside the RF modulator here. So in the RF modulator, if something is drawing this too high, then you will not be able to have a high enough amplitude down here, of course, because these are coupled together. So what likely is the culprit? As normal, I like to go to the schematics and see first what possibly can be wrong before I actually do any fault finding. And I will check Q8, and I will check the 12 volt up here. And otherwise, I can of course measure the signal. I can put my scope probe here when we do have an audio signal, and I can measure this here. It should be slightly lower here, and it should be slightly lower again here, but not by much. And also when it's coupled like this, the emitter follower amplifier that only amplifies the current, then the amplitude is not inversed as it is if you had taken the signal out here and had a resistor up here to 12 volt. Then this would have come out in opposite phase, but this will be the same phase, only slightly lower. So we can of course measure that with the scope, but I think the first thing to do is measure this transistor with an ohm meter, maybe take it out and test it in a transistor tester to see. So that will be my next course of action. Yeah, that's 900 millivolts. And this is 640 millivolts. So this actually looks good. And the rest of the resistors, the R6 is the one that was going to ground. It should be a 1K resistor. Yes, it's a 1K resistor. That's good. And you have the bead FB13, it's actually this one, and it has 0 ohms. And then you have a 10K resistor, that's R7, and that is this one, and that is 10K. And then you have the R38, that should be the one that goes to ground on the output, and that is this one. And here you can see they have made some modifications. They have put one other resistor on top of this 1K, but it's this is not a resistor, it's actually a capacitor, and you can see they got it right in this later version of the schematic, where this is pictured as a 220 picofarad capacitor that stands in parallel over the emitter 1K resistor of the transistor. You have the capacitors that's here, and that capacitor is C37, and that is this one. And it's certainly not shorted, at least not for DC. And this transistor is it's a C1815 something, and it's stated that this is the emitter, and if this is the emitter connected to this pin of the transistor, so this is the base, so that means that the collector is the middle pin. So from collector to emitter there should be more than this voltage. So I will try to desolder this transistor and actually test it in a transistor tester, yeah, just to make sure. This should be the good stuff soldering wick. Just need some water on the sponge on the soldering iron. Using my trusty old Weller, and I just remove the tin from the top of the board first. One pin left that had any solder on it is this middle one. That of course had a trace connected to it that made it a bit harder to desolder. And I do have my universal tester here. I can just place the legs in like so and make the device find whatever it can find. And it does says that this is NPN transistor, and it actually has the 640 about millivolts of from base to emitter that we already established, and it has a voltage amplifier of 361, but that we are not using. So we just see that it does actually work, and there is nothing seriously wrong with this. So we do actually then have a case where we have measured all the components in the signal path, and we have still found no evidence of anything wrong. That does not mean that everything is right. We also have the capacitor to consider. Normally electrolytic capacitors that fail is a better conductor for DC than it is for other things, but also signals like AC. It should go through if there is a resistive part of this capacitor that is winning due to its aging. But there can be other faults as well, because it can be the bias of the transistor that is affected, because there is coming some DC voltage the wrong way into the circuit. So anyway, we have to see what we can do about this capacitor to see if it's working or not. What we do see here when we measure this is that the emitter here is of course coupled here, and this is coupled here again to this side of the C13, and this is the output that goes to the plug on the output here and also to the modulator. And this is in fact electrolytic capacitor, and it's the only one of these that is a bit white on the top. So I do wonder if I take this capacitor out. It's actually a 10 microfarad capacitor. I take that out and replace it with a new one, and we see what happens to the sound. And this is 10 microfarad 25 volt capacitor, born in China. It has a Yasek or something brand, I'm not sure. Just lifting that like so. And this was stapled so it has the minus up this way, and I'm just going to stitch it in from the top here. Like so. And I'm actually going just to test again to see how this goes. I will connect just the test cartridge. Everything else should be connected. I do have this connected to my stereo speakers here. I might have to adjust the volume. I'm not sure how this is going to sound. There might be no sound at all. What do I know? And no sound at all. And you might have guessed what the reason is. The moron that is working on this, of course, forgot to solder in the transistor after I desoldered it. So the transistor is not soldered in, so that we have to fix. Now it's testing again, so we just have to wait for the test sound. Now the sound is back in, and I have to eat my words. I said that I never encountered a capacitor with fault in a C64 before, but this capacitor was obviously at fault. And we will try again with the original SID to see how that sounds. careful with my arm SID. The arm SIDs are much more rare than the original SIDs. And we test again. And the sound, I have only coupled it so that my camera and mic is detecting the sound from my speakers. You know what? This SID chip is working, and it's working fine, but the noise channel and the noise in the end was kind of low, and it's kind of disturbed, and that was not present on the ARM SID. So this actually is kind of a lesser working mouse chip, but you know, I think it's well within specification, and especially for one of these earlier chips. So I think I'm just going to call it a quits here while I'm ahead and have remembered to solder back all the components. So this one, I just take it as a win. There was a fault on this motherboard, and who would have known? My first bad capacitor on the C64 was actually electrolytic capacitor in the sound circuit. Who would have known? So let's see how this measures in my multifunction tester. I just try to place it like so, and this should orient itself the right way, but it's of course 56 picofarads. Turn it around and measure again. About 55 picofarads. And that's what we get with this tester. I also have this tester. This is a more sturdy device. I'll try to hold it like so, but I do think I will have a problem with keeping this in check. You have to see. Turn it on, and that was not a good reading. I try again this time. It's measured like 67 picofarads, a bit higher value. Try to make contact again. I have to straighten out these legs a bit, maybe. It's actually meant for a bit thicker legs. 68 picofarads. So it's getting a bit bigger signal than I get first. Yeah, we just do one more quick measurement with the multitester to establish a baseline. 57 picorad. So it's increasing, and that might be while we're putting power on it. So we just use what we have. Yeah, so let's do a simple calculation. What does this actually mean for resistor that is meant to be 10 microfarads but is only 55 picofarads? Let's first do the calculations with the resistance that should be there. And XC, it's the series resistance of capacitor given at a given frequency is calculated as 2 times P times the frequency times the capacitor. And here you have to give the frequency in hertz and the capacitor in farads. So in our case it will be 2 times P, and we do this by 1000 hertz. It's a quite common signal to do when you do audio measurements, and it's the same signal that was on the old test signals on analog TVs, and it's also quite close to the first beeping sound you hear when the sound test runs. And the capacitor 10 micro, and 10 micro is 10 times 10 in minus 6, and that is, if we put in numbers here, you will have 2 times P times 1000 is 6280. We don't do more than 2 decimal P here, and this is actually the same as 0.00001. That's 10 times minus 6 multiplied with 10 times, and this gives us about 16 ohm. That is the series resistance, and of course with a higher frequency this will be changed. And we have the same with the capacitor when it's fault. Then it was this calculation here. We have the same in front here. It's 6280. That's 2 times P times 1000. But this capacitor in 15 picofarads is actually 10 times minus 12. So 55 picofarads is equal to 55 times 10 in minus 12. You have milli, you have micro, you have nano, and you have pico. So this will actually be 0, 0, 0, 0, 0, 0, 0, 0, 0, and that's 9 zeros. We need 10 and 55. So we have to make this a bit longer, and that actually is about 29 mega ohms. So this is the resistance we have with the new capacitor. So there is no mystery at all that this signal was much weaker, and the reason we get some signal through at all is that the current is very low, so the voltage drop was not 100%. But here you see what the fault actually was. Instead of a 16 ohm resistor at 1000 Hz, we had 29 mega ohms resistance at this frequency. And that's it for this video. It was a rather different video from what I intended to make, but I did learn something, so I hope this was something that was of interest for you too. This was the strange breed of C64 with 5 different kind of RAM chips from the factory, and a lot of other chips socketed, probably due to chip shortage, and that they had to put the chips in after they left the factory for the boards. And this was a revision C 251137 board, and as I said before, this is probably the only one I have. I remember doing the revision B, and we also looked at revision B earlier. But no, this is another working C64, and this one was one that we didn't even know had a fault until we put in the test harness and listened to the sound. And that is some fault that probably would have been easy forgotten in some of my earlier videos. So, thanks for watching. Hope to see you again in my next video. Please hit like and subscribe, it will really help out the channel. Thank you.